go. Game time is right. All right. Test looks just like these practice tests. So page 1 is this big problem. How do we start this big problem that we have to have asymptotes and all that stuff? We start by factoring it. And chances are, what's going to happen when we factor? Something's probably going to cancel. All right, now Mrs. Ford is old. I've done this for years and years and years and years. So I kind of did this 2 things in my head. The denominator was 2x squared minus 2, right? So what do I do first? Take out a 2, and that left me with x squared minus 1, which I knew was the difference of squares. Everybody okay with that? Now, did indeed something cancel? Yes. Alright, so something did cancel. So that leaves me with x minus 5 over 2 times x minus 1. Oh, I almost forgot. It's been such a long time, but I haven't seen you. And our football team, we have some football players in here, accomplished a great feat last week. And tonight, I have another big game. So I have a treat for you, and I don't know if you want a cookie or a brownie, but you can have just one. Not one of each. I don't have enough. So just one or the other. Pass them around. And that's to celebrate. And hopefully, men, hopefully I'm baking again this weekend, right?
Yes, ma'am.
You did. And you did. And we'll celebrate that too. You're right. I'm a little behind. I had volleyball and football and I was gone, but yes.
Thank you.
Thank you.
Delicious.
All right. Now, back to attention. Back to attention. We got a test on Monday, win or lose, and hopefully win. We are going to have a test. So here we go. Where will the hole be? We got to get this right. We can't mess this up. Look at what you canceled out. Where will the hole be?
-1.
-1. You okay to shine?
Which one?
Oh, I know, it's such a decision, isn't it? So the hole is going to be at -1, right?
Mm-hmm.
Now, how do I get the y coordinate? Because I do have to graph this. Plug it back in right here. Plug it in here. Do not plug it into the original problem. Never, ever, ever plug anything in the original problem. We're plugging it in here. So when I put in -1, I get -6 over 2 times -2. I put in -1, -1. So that's -6 over -4, 3 halves. So I'm going to plot a point at -1, comma, 3 halves. Right? Now, what else goes into the graph? It's all listed there. You can see what that stuff goes into the graph. So what am I going to put in now?
2 for, wait, y equals 2 for the horizontal.
The horizontal would actually be y equals 1/2. Why is the horizontal y equals 1/2? Because we have x over 2x. We have 1x over 2x. Got that, Jake? Hey, Jake, put the book away. We're doing the practice test now.
All right.
Okay? It's already late. Almost already late. So 1x over 2x is our 1x over 2x is our horizontal asymptote. Got it? Okay, what else? Vertical asymptote would be where? At 1, x equals 1, because vertical asymptotes go where the denominator equals 0. Oh, you're welcome.
Thank you. I love you.
Vertical asymptotes go where the denominator equals 0. Okay. What else? When you look at this, doesn't it seem like 5 is a special number?
All the x-intercepts.
That's the x-intercept. 5 makes makes y equals 0, so that is your x-intercept. And then I need one more thing. I need my y-intercept. How do I find my y-intercept? I put 0 in for x. So I'd have negative 5 over 2 times negative 1. So what is that? 5 halves. So my y-intercept is at 5 halves. Now, if you are still struggling with those things, you absolutely have to memorize the rules. To get a vertical asymptote, let the denominator equal 0. To get an x-intercept, let the numerator equal 0. To get the y-intercept, let x equal 0. To get the horizontal asymptote, it's the x over 2x thing. I'm not sure how you want to memorize that. Okay? You got to memorize those things, guys, if you haven't already. Now, draw the picture. Is there enough to draw it?
Yeah.
I think so too. Remember, when you draw it, the curve has to approach the asymptotes. So don't be something crazy. Don't do something crazy. And like here, sometimes you want to curve this back. Don't. It follows that line right up. And down here, it follows right here. Remember, when you draw this, it will have 2 pieces. Always 2 pieces. They'll be in opposite corners. So don't draw one and forget to draw the other one. You okay with that?
Yeah.
All right.
I'm sorry, can you explain one more time how to find the x-intercept for
Whatever makes the numerator 0. Come straight from the numerator.
5.
All right, number 2 is an inequality. So totally shifting gears now. Totally shifting gears. We're not sketching this. There's no asymptotes. None of that. What do we do with inequalities? That's right. 2 things. One of them is a number line. We're eventually going to have a number line. What's the other thing with an inequality? Get it to 0. So the first thing I'm going to do is subtract that 2x so that I have a 0. This is an x squared, so I am absolutely positive there's going to be 2 dots on that number line, and I need to figure out where the dots go. And how do I figure out where the dots go? I use the F word. I factor, right? I factor. Now, how does that factor? Take out an x minus 2. Kids, there has been a problem exactly like this on every sheet. One of the sheets had a 6, one of the sheets had a 4. Doesn't make any difference. No. This problem is on the test. This is how you do it. Now, where are your dots?
0 and 2.
This time they're at 0 and 2. Are they colored in dots or open dots? Colored in. Why are the dots colored in? Because it is an or equal to problem. Now, I'm going to shade someplace on that number line. How do I figure out where to shade? I plug in a number. Any number I want that is not 0 or 2. So Paul says plug in 1. That means right here, I'm plugging in a number in that spot. So if I put in 1, here I am. Actually, you can plug it in anywhere. I think I'll plug it in here. If I plug in a 1, I get 1 times negative 1. Is 1 times negative 1 less than 0? Yes. So this works. What does that mean about these two? They don't work. So my answer is everything from 0 to 2. Why am I using brackets? closed dots. If the dots were open, I would use parentheses. Got it? Next, little harder problem. But is it still an inequality? Yes. So I am still going to get 0. And I am still going to draw it on a number line. Finding where the dots go on the number line, though, is going to be a little bit harder because I need to subtract these things, right? Shawnee?
You put the -2/1.
Yep, I think of that as a fraction, 2/1.
And then you multiply the whole thing by x plus 5.
I need to get a common denominator, so I am going to multiply the top and the bottom. I have 2/1. I'm multiplying the top and the bottom by x plus 5. Right? So now I can write one fraction, and the denominator is x plus 5. They have the same denominator now. What's on the numerator? Well, I have x minus 1 minus 2x minus 10. Very good. Remember, that's a distributive right there. Asia, you with me? Now, let's collect like terms. I've got negative x minus 11. Now I'm going to get a dot out of the top, and I'm going to get a dot out of the bottom. The dot out of the bottom is easy. -5. The dot out of the top, too many negatives, confuses me. So over to the side, I'm going to figure out where that dot goes by setting it equal to 0. So negative x equals 11, and x equals -11. So the dot for the top is at -11, and the dot for the bottom is at -5. So they go on in this order because that's the order they would be on the number line. Open dots or closed dots? Open. There's no or equal to in the problem. No or equal to means no closed dots. Now how do I figure out where to shade? Plug in. I can plug in any number I want except -11 and -5. Now I like to use 0, but we noticed the other day when we used 0 that some of you are not shading right, and it's because you're not remembering where 0 is. In this problem, 0 is out here, right? So you can go ahead and plug in 0. That's fine, that's easy, that's what I like to do. But make sure you understand this is where you're testing. Not in here. 0's not in here, 0's out here. So when I plug in 0, I get -11 over 5. Is -11 over 5 greater than 0? No. So the spot where 0 is doesn't work, which means this spot does and this doesn't. So my answer is -11 to -5 in parentheses because the dots are open. You with me? That makes sense?
What'd you say the answer was? -11 or
-11 to -5, the part I have shaded. Now C is in some ways easy because you already have a 0 and it's already factored. So I know when I draw my number line exactly where to put the dots. Where do the dots go? -1 and 2? That's easy. What makes this problem harder is what? You have to try each section. In our other problems, kids, we could try one number and then we knew we were alternating, shading, not shading, right? This one you can't do that because of this. So I know exactly where the dots go, but now I'm gonna have to pick a number here, here, and here, because it doesn't alternate. I don't know what it does, but it doesn't alternate. Okay? So, if you wanna pick 0, that's fine, 0's in here, right? So if I pick 0, I have -2 squared, which is 4, times 1. Is that bigger than 0? Yes, so that works. But I gotta try a number out here too, like 3. 3 minus 2 is 1, squared is 1, 3 plus 1 is 4. Is that bigger than 0? Yes, so that works too. Now I'm going to try -2. -2 minus 2 is -4 squared is 16. -2 plus 1 is -1. Is that bigger than 0? No. So the answer is this section and this section. So -1 to 2 or 2 to infinity. Now be careful. Sometimes we can say, oh, that's just -1 to infinity. Not this time. Why can't I say that?
Not all of them.
It's not all colored in. 2 isn't colored. 2's an open dot. So it's 2 separate sections. This is not one section, it's broken here. So -1 to 2 and 2 to infinity is the answer. Alrighty dighty. Oh my. Now probably the hardest question on the test is the next one. This is the one where we're going to have to get it set equal to 0, so we'll go ahead and do that. So I got my 0. I know I'm going to have a number line, and I know it's going to have 3 dots. How do I know there's going to be 3 dots on this number line? X cubed. It's x cubed. Now what makes this hard is, I know I have to factor it, but it doesn't group. Right? So what do? It doesn't group. PRRs, guessing, synthetic division, I have to go through that whole process. Now I promise you, I'm not going to have you're not going to have to guess a million times. Right? You want to guess 1, 2, and 3, -1, 2, and 3, whatever your PRRs are. Okay?
Let's just do -23.
Ooh. Oh, no. I actually got it set equal to 0. So I moved it all over. Remember, with an inequality, we want to have 0, right? So I went ahead and moved everything over. Did you catch that?
Yeah.
Okay, that's what we want to do. Okay, so now in my head, I'm going to start guessing some numbers. I think 2 works. I'm going to try 2. So I'm doing my synthetic division. And sure enough, 2 worked. All right. So what do? I guess until I find a number that gives me 0. Sometimes I have to guess more than once, and that's okay. We just guess more than once. What do I do now? I factor what's left, which is x squared minus x minus 12. And I factor that into what? -4 plus 3. All right, now here is where I want you to be alert. This is an x cubed. It should have 3 factors because it has 3 dots, right? You have found x minus 4 and x plus 3. You got those from this part right here. What's the other one? It's this guy right here. Don't forget about the one you guessed. What factor would that be? X minus 2. Very good, Chris. X minus 2. Now, should these dots, oh, by the way, they would be where? Negative 3, 2, and 4? Negative 3, positive 2, positive 4? Should they be open dots or closed dots? Closed. It's an or equal to problem. Now I'll pick a number, any number I want that's not these. So 0. 0's in here, right here. I'm checking right here. So if I put in 0, I have negative 4 times 3 times negative 2. What is negative 4 times 3 times negative 2?
24.
Positive 24. Greater than 0?
Yeah.
So it works. What about this section? So my answer is everything between negative 3 and 2, or everything from 4 to infinity. That's probably the hardest one on the test. So get your 0 and then start guessing until you get one that gives you 0. Factor what's left. Don't forget that guy. You should have 3 factors. Put them on the number line and go. Is that all right? Okay, so now we got an easy question. That was a hard one. Now we got an easy one. This is totally different. It is not an inequality. I don't need a number line. I don't need a 0. I do need to do what? Get rid of these denominators. What can I multiply by to get rid of a 3, an x, and a 6? 6x. Now, are there other things that you could multiply by? Yes. 6x is the smallest one. But you could multiply by 12. You can multiply 12x, 18x, any of those. But we're going to multiply by 6x. Don't do a thing until you cancel. Don't do anything with the equation until you cancel. So 3 goes into 6 twice. X's are gone. 6's are gone. What is left? What is left? What's left here? 4x plus 24 equal to 5x. So your answer is x equals 24. You okay? Same thing now, but a little bit harder. As I am copying it down, I'm going to go ahead and factor that middle denominator. Are you okay with that? Remember, we factor anything no factor. So I have factored my middle denominator. All right, what do I do now? Multiply by x plus 2 and x minus 2. That's my common denominator, so I'm going to multiply everything by x plus 2, x minus 2. Do not make a move until you cancel. Once you have multiplied everything by your common denominator, cancel. So slash away. There we go. every denominator is gone. Every denominator is gone. What's left? X squared minus 2x minus 1 equals 2x plus 4. Now what do I do with that? Combine my terms. Let's get it set equal to 0. So I'm going to subtract 2x and subtract 4. So I have x squared minus 4x minus 5. Don't just copy it down. Make sure it's making sense to you. I will not be doing the test on the board. What now? Factor it. So x equals 5 or negative 1. Beep, 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 beep. What do you notice, Paul?
I was looking to see if it was up there.
I didn't write it down. And, oh, wait. Both those work, don't they?
Yeah.
Yeah, because the only numbers that wouldn't work would be negative 2 and positive 2. So I have 2 good answers this time. Lots of times one of them doesn't work, right?
Yeah.
But this time they're both good. Okay, all we have left are the word problems, and they are easy. They are easy. Okay. We have 2 kind of basic formula things that we have to remember. We've used them over and over and over again. We have 1 over alone plus 1 over alone equals 1 over together, right? That's one of our, formulas. And the other one is amount times percent plus amount times percent equals amount times percent, right? So here we go. A. Which one of these am I doing for problem A?
First one.
This one, right? So Chandler can do it in 10 hours. 1 over 10. If Maura helps, it takes 8 hours. Where does the 8 go? Together. So Maura alone is my x. Would you agree? Now, we did a problem like this a minute ago. You're going to multiply by something that will wipe out a 10, an x, and an 8. There are lots of choices. What can you think of that we'll get rid of? Has to cancel them out. 40? Will 40x get rid of everything? Yep. Now, you could also use 80x. There are lots of things you could use, but 40 will do it. 10 goes into 44 times. The x's are gone. 8 goes into 45 times. The whole point is gone, gone, gone. Denominator's gone. Multiply by whatever will get rid of the denominators. So now what do I have left? 4x plus 40 equals 5x. So x equals 40 hours.
I don't know where the 40 came from.
It is a common denominator for 10 and 8.
Okay, I got you.
8 will go, or 10 and 8 both go into 40.
Yeah, okay.
Now, they also both go into 80. They go into 400. They go into lots of things. find one, pick one, doesn't have to be 40. You're gonna get the same answer regardless.
Okay.
Alright, and then finally, how much this must be mixed with this to get this? Here we go. Step one, we're gonna fill in all of our percentages, right? So our percentages are 53, 30%, and 45%. Is everybody okay with that? Now the only number that I know is 12 gallons. And the 12 gallons goes with the 45. Right? And this is X, how much, 53%, how much, that's X. Now, when the empty spot is here, remember what your choices are. 12 plus X, 12 minus X. What is it when it's in the middle like that? 12 minus X.
Minus X.
Remember, this is the total, so this is always going to be the add one. So we have 0.53x plus 3.6 minus 0.3x equal to somewhere I'm taking my calculator. What is it? 5.4. So 0.23x plus 3.6 equals 5.4. So 0.23x, I added these together or subtracted them, equals 1.8. So x equals 1.8 divided by 0.23. So it looks like about 7.8 gallons. Did I do that right?
Yeah.
About 7.8 gallons. Robbie?
Why is the 30%?
Because I had to distribute 12 minus x times that. So it's 12 times 0.3 and then negative x times 0.3. So it's a negative times a positive, so it would be negative. That's a distributive. Anything else? Quincy, you awake? All right, so we're all set on that. All right, then what I want to do now, in our remaining moments, is get back your last test.